Test. Hi, can you all hear? Can you all hear me? Hello, good afternoon. This is the SC1007 Data Structure and Algorithm, Lecture 1. Good. I hope it is working. So the first part of this module, because the class size is quite large, we have about nearly 800 students. So we probably will use this YouTube to stream the lecture. I will start the lecture at 12:30. So if you watch this video, you later, then that means you can skip the first 12 to 13 minutes. Yeah, I just try the slide and yeah, all the audio. I hope everything is okay. Yeah, not surprising, definitely there's some delay. Normally the delay can be 3 seconds to 15 seconds. That's because the YouTube there's some buffer, so there's some delay. So when you post, you can post your question in the chat, but there are some delay. So sometimes I already moved to the next slide, but your question just come out. So I may not be able to answer your question. Yeah, hope you can understand. Should be here. Oh. So today, this 1 hour lecture, I will just give an introduction about this module, the assessment, and so on and so forth. So if you have any question, you can put in the chat. I will try to answer it. But just take notes, we have few hundreds of students. So sometimes I may miss your question. If that is the case, you can send the email to me. The first half. Yes, I will cover the first half. Then the Dr. Lu will cover the second half of this module. Later, I will give the details about this module. And the material will be uploaded in the due course. We are reviewing all the material this semester. So yeah, we may not be able to upload everything overnight like other modules. So yeah, just stay tuned, then take notes the any new upload material in the NTU Learn. Hey, good afternoon. Just wait for a while. I will start the lecture at 12:30. Now we have 131 students, maybe. Yeah. 136. This sem we have a very big class. We have nearly, I think we have 700 plus students taking this module. So the lecture will be conducted online. Tutorial mainly also online. Only the lab will be conducted physically in the lab. Um, of this module, you're going to use the programming language we use is the C programming, which you have learned it in 1003. So any software in the test we provide you the code block. You can consider to use it. Code block. But you also can use other IDE to write your program. But during the test, we only provide one IDE, which is code block. So just take notes. Yeah, it's good that you familiar the interface, so you may not have any difficulty during the test. But you still can use other IDE, like some people use the VS Code or any C compiler is fine. Will this link be used for the next lecture? This channel, I will trying to put all the live streaming in this channel. So the link I give you, you can click the channel, and then yeah, all the video, all the live streaming lecture will be uploaded in that channel. $200. My estimation, there are about 7 to 8 second delay. Yes, only C programming. Will we use? No, we will not use the Harpass. We will use another platform. We will let you know. Yeah. Later. Yeah. But yeah, the platform will be similar to Harpass, but not Harpass. By code block, you mean the code blocks? Yeah, code block. Sorry. Yeah. If it's similar, we have some time to get familiar. Definitely you have a lot of time to be familiar with the platform because all the assignment will be used the same platform. So yeah, you definitely have a few weeks to use the platform to try out all the assignment. So that should not be an issue. If all the assignment done by your own, yeah, you should not have any issue. Yes. Later after the lecture, I will upload. I will just in fact YouTube will automatically store the video. But sometimes I need to take some times to update their server. So yeah, but I think a few hours later you should be able to watch the lecture. We don't have pre-record lecture to watch, right? I would say yes, but actually I think you can see that in the channel there are some previous semester lecture. If you want to watch it, you are free to watch it. But yeah, every sem we will review the content, so it may not be exactly same as the previous semester video. Telegram we don't have. Every week, yes, we have 2 lecture. So I will update the all the streaming link in this channel for my part. Okay, so now it's 12:30. I'm going to give the first lecture of this module, SC1007, Data Structure and Algorithm. In this lecture, I will just give you an overview about this module and what you are going to learn in this module and our assessment. Yeah, this is my name. I'm Lok Yuan Ren. Yeah, this is my email address. So if you have any question about this module, assignment, tutorial, yeah, you can drop the email to me, yrloke@ntu.edu.sg. Or if you need any consultation, physical consultation, you also can come to my office. And then the second part of this module will be covered by Dr. Lu, and this is his email and his office. Okay, so this is the course schedule. So this week 1, we will give you an introduction, and then after that, we'll cover the first half. Will mainly focus on the data structure, linked list, stack and cube, tree. But this time we're trying to introduce some algorithm. We will bring the analysis of algorithm and some algorithm problem like linear search, arithmetic expression conversion, binary search, and so on and so forth in the first half with the data structure. And So the analysis of algorithm, you expect that you need to have some mathematics knowledge. It's not, it's just simply coding in this module. So it also require you to do some calculation to analyze the algorithm. So I already upload some mathematics revision, the notes for you to revise your maths. Yeah. And then in the second half of this module will be focused on the graph representation. So you cover the graph representation and some graph problem like breadth search and depth search, backtracking technique, and permutation problem, dynamic programming, and some bipartite graph problem, which is a matching problem in the last lecture. And in this module, we only have 6 tutorials. So just take notes. Not every week you have a tutorial. From week 3, the tutorial will start from week 3. And then in the first half, we have the tutorial in the odd week. Then in the second half, we have 3 tutorials from week 10 to week 12. For the lab section, we will start from week 3. I think week 4 due to the Chinese New Year, so there's no lab section. Then we have lecture, the lab 2 to lab 4, and then second half also have another 4 lab section from week 9 to week 12. So we have 8 assignment in this module. So all these assignment and the test will use the same platform, which is called Hacker Earth. Yeah, we will give you the details, the link, how to use them, when the time close. So just take notes that in this module there are 2 tests. The lab test 1 will be held on 3rd March, Thursday, and then lab test 2, and quiz will be conducted at 21st April. Okay, so just take note, these 2 dates, very important. The details about the venue and the time slot of the test will be released probably in week 3 or week 4 after the ad drop period end. So this module, the learning outcome of this module, the first half we aim to let you be able to know all the data structure and you'll be able to select appropriate data structure. And in the second half, in fact the first half, we also expect you will slowly able to implement the algorithm, realize the algorithm to write a program in C programming. And you also be able to know how to conduct the complexity analysis of algorithm in this module. So this module, will it be a lot of maths? I would say when we analyze the algorithm, you'll find that actually you need to use a lot of maths. But I would say this module is more on the introduction module. So the analysis part, we just trying to introduce you how to analyze the algorithm. How do you know the algorithm, which algorithm is better than the other one? So that is the learning outcome of this module. And the assessment component will have 8 assignments. So this 8 assignment contribute 40% of this module. The CA. Then you have 2 lab tests. Lab test 1 and lab test 2 will be another 40%. And we have a final quiz with the lab test 2. And this quiz will contribute another 20%. And the final quiz will cover everything from part 1 to part 2. But lab test 1 will cover the first half. Lab test 2 will cover the second half. And lab test 1 and lab test 2 is the programming test. And yes, the final quiz is the MCQ, will test you the concept. Yeah. It may involve some probability, but not a lot. Okay, so that is, and take notes that the attendance of the test, all these tests are compulsory. If you, especially the last one, if the last one you are absent in the test, then you, yeah, for sure you will fail this module. No, there's no LAMS quiz in this module. So how long are we given? So you can see that normally I will trying to release the assignment about 2 weeks. Yeah, hopefully it will give you about 2 weeks times. That means the first assignment will be released maybe after I cover the link list, and also after the end of the airdrop period, I will start release the assignment weekly. So every assignment you have 2 weeks to do, about 2 weeks. No, it's a closed book. So we haven't touched anything. It will not use a lot of probability, but some basic probability you have learned in O level or A level, you should know those basic probability. Yes, assignment is on the Hacker Earth. The lab test, everything will be on the Hacker Earth. So this module is quite important. If you look at your program's curriculum structure, yeah, it's the prerequisites of several modules. The next level will be 2101, algorithm design and analysis, and then your database, AI, and so on and so forth. All these, the prerequisite is SC1007. And yeah, so this part, you can see that you have taken the SC1003. So this part is more on the software development, or ODP, software engineering, advanced software engineering. Another path is this one is all the algorithm. Yeah, algorithm, the theory, the database, AI. The prerequisite is this SC1007. On the other hand, for more on the computer engineering courses like OS, you need the prerequisite also this SC1007. So this module, yeah, is one of the important module in the level 1000. Yeah, no, we will not provide any cheat sheet for the function. Yeah. Okay. So this module, the lecture is more, we're trying to focus on the introduce the concept to you, and then the tutorial is for you have, so not every week you have the tutorial section, but we're trying to have this tutorial section for you to clarify your doubt with the tutor, and then discuss with the tutor, and also trying to, if you have any things you don't understand, you can ask the tutor. So, and then the lab section is more on practice the coding. Yeah, there are TA to help you. So, but the lab section, there's no grading. So but we still strongly encourage you to attend all the lab section. It's very important because this module, the lecture and tutorial mainly online. Yeah, due to the class size. So the lab section is the only chance, the place for you to physically attend the class and there are someone for you to clarify your doubt physically. Yeah. Then the lab test and quiz are for the assessment. So That is the objective of each section in this module. So lecture, sometimes you'll find that in this module, I said, you will find that certain things like stack and cube, the concept is quite easy to understand. But sometimes the difficult part is the coding part. Some module maybe like I think like 3 also, maybe the concept is not difficult, but the implementation can be very difficult. And sometimes like analysis of algorithm, the concept is harder, but yeah, not much thing in the programming. Yeah, there's no programming in the analysis part. It's purely the mathematics analyze the algorithm. You don't need to do any coding. So this module, you'll find that certain topic, the lecture is important, and certain topic, the lab is more important. Tutorial is online, yes. Yeah, so that is the interesting part of this module. Yeah, not everything. Yeah, I think sometimes you find lecture is more important. Sometimes you find that the lab section is more important. And so this module, there are basically 2 components in short. The data structure, I think you need to know those pointer, the structure, and also we will introduce you some classical data structure. Linked list is one. Stack and cube, you can think that is the extension of the linked list, or it's just a special case of the linked list. So linked list concept is very important. And to understand the linked list, first you need to understand all the pointer, which we will cover in the next lecture. And then after you know all this linear data structure, we will introduce you the nonlinear data structure, which is the tree structure and the graph. And you need to know how to implement all this data structure. And not only you need to know how to implement all this data structure, you also need to know how to select appropriate data structure to solve the real world problem. Another part of this module we will cover is about the algorithm. So algorithm, later I will talk more details, is not that may not be what you thought, like just implement the program. It's also involved how to analyze the algorithm, like the time complexity, space complexity, we will cover in this module. And also introduce you some typical algorithm and their application. So and we also introduce you several algorithm design strategy. But all this introduction, because there's another level in 2101, they will cover more advanced algorithm. And this module, all the program will implement in C, using the C programming language. So please make sure your C programming language, you still remember how to write your C programming language. So, okay. So far, any question about this module, the assessment? Anything? Let me see the question. Can reverse. Okay, I can use. Tutorial is online already. Answer anything? I think I already answered most of the question here. Okay, so next. So next, I'm going to give you a short introduction about algorithm. What is an algorithm? And some different problem type of some problem types in computing, and then also some algorithm design strategy we will cover in this module. So if you simply search what is an algorithm, this word is appear in yeah, after 1957, but actually it is derived from some mathematician. So actually this algorithm is come before we have computer. Actually people come out algorithm is before we have computer. Computer is invented in after I think 1958. So actually before that people already think it start having the algorithm to solve some problem, like finding the greatest common divisor of two number. Yeah, that is probably the first algorithm we have. Yeah, basically what is an algorithm? In the dictionary it said is a process or set of rules to be followed in calculation or other problem solving operation, especially by a computer. So if you check, you read the book, the textbook, yeah, algorithm is a sequence of unambiguous instruction for solving a problem, for obtaining a required output for any legitimate input in a finite amount of time. And if you read this, another book is the Introduction to Algorithm. These textbooks, hope you can see. Yeah, this book, yeah, is one of the very classic textbooks for the algorithm. The definition of the algorithm in these textbooks is that an algorithm is any well-defined computational procedure that takes some value or set of value as input and produce some value or set of value as output. So you can see that algorithm is just it need to be a unambiguous instruction and then a well-defined computational procedure. Yeah, must be unambiguous. The keyword, yeah, must be well-defined. This means there's no something big, small, good enough, yeah, large enough, that kind of thing. Everything must be well-defined. And another keyword is, of course, you must have provide some input, and they always will produce some output, and in the finite amount of time. Of course, we in this module, the algorithm will focus on those problems are well defined and they can be solved in a finite amount of time. So in short, your algorithm, of course, the logic must be correct, which means your output result must be correct and consistent for every given input. That means every time you give the same input, your algorithm should give you the same output, and the output must be correct. Next is the precision. All the steps must be well defined, and you need to be systematically do every step. And the step should not contain any ambiguous word like maybe, roughly, big, small. Everything must be well defined. And the third things is finiteness. The program must be terminated in a finite number of instructions. So what is the difference between algorithm and the program? Algorithm basically is, you can think that it's an idea. You come out the idea, you come out the list of the procedure, the step, and program is an instant of the algorithm for you to realize, for you to implement the algorithm in some language, in C, in Python, in Java, and then you can execute that program in computer and let the computer do the job for you. So in this module is algorithm, not the programmer. Yeah, so but of course you need to be able to implement the algorithm into a program, and let the computer do the job for you. But we not only learn the implementation, we also learn how to analyze the algorithm in this module. There are some questions. Yes, be familiar. Yeah, you may, for those who are using the Mac, you may have some problem on using the code block. Quiz will be on the code block. What? Yeah, as I mentioned earlier, final quiz is yeah, it's just an MCQ, so there's no code block. The programming part is in the lab test 1 and lab test 2. Final quiz is purely test your concept. As you can see that in this module, you are not only need to be able to implement the program, you also need to be able to come out the algorithm by your own, and also need to be able to analyze the algorithm. So for example, you want to do some arithmetic series. Yeah, there are a lot of ways for you to sum the number from 1 to n. The most simplest way is you just simply write a for loop and then trying to sum 1 plus 2 plus 3 plus 4 plus 5 plus 6 to n. Then you get the answer. But if you have learned about, so why the mathematics is important. If you learn the maths before, you should know that actually if you know the arithmetic series, the formula, you just need one line. Yeah, the number, you're trying to sum from 1 to n, when you want to sum 1 plus 2 plus 3 plus ... to n. So they are n term. So the formula is n over 2. The first term is 1, the last term is n. So I just need one line. I can instantly find out the answer. If you don't know, you just write the for loop. You also can get the answer. But it's quite obvious that using the second algorithm, your computational times will be much shorter. Your computational times is not depend on the n. This algorithm, you expect that largest n will take longer times to find out the answer. But the second algorithm is constant. Every time you give me any n, I can complete the computation in one line. So that is why you not only need to know how to implement the program, you also need to analyze the algorithm before you implement. Sometimes one problem you can have a lot of solution. Yeah, I also can write the same algorithm, in the recursive way. Yeah, this is the recursive version. But which one is the best one? Instead of implement them and test it out, sometimes you can use the analysis of algorithm to find out the best one before you implement it. So that's why you need to learn the analysis of algorithm in this module. So if you look at it, I think it's quite obvious. This one is the best one. But what do you think? The algorithm 1 and algorithm 3. The recursive version and the iterative version, which one will be better? Algorithm 1 and algorithm, of course, quite obvious, algorithm 2 is the best one. Then if you compare algorithm 1 and 3, what do you think? Some said there's one said algorithm 3, the recursive version. There's one set. Yeah. Okay. 1, 1, 1, 3, 1. But yeah, in fact, you will find that actually later you may learn more. You will find that actually 1 will be better, because 2, every time you do the recursive, it looks very cool to have a recursive function to call yourself, to call the function itself again and again. But every time you call the function, actually the computational times may be no too big different compared to the first one. But the third one, the algorithm 3 will take more memory, because every time you call this recursive function, they will use more stack memory to store a lot of redundant data information in the stack memory. Yeah, that may cause the stack memory overflow. Yeah, someone have mentioned in the chat. Yes. So actually, this is a little bit better than algorithm 3. If you consider the stack memory, the space, computational times wise is about the same. Because this one is also every time you can see that you are trying to n plus, n minus 1, n minus 2, n minus 3. You just sum it up until you reach n equal to 1. Then you start return. So don't we have enough memory to run multiple function call and not worry? Theoretically, yes, but in fact, but you still use a lot of memory. That means you use a lot of, that means your program take more memory. And in practice, we have some system, especially if you study those like embedded system, you have a limited hardware resource, then that may be, you may run out of memory. Or if your n is a very large number, yeah, this one, that means every time if your n is 1 million, you expect that you need to recursive call this function 1 million times. And in other words, you waste a lot of memory to solve a simple problem. Okay, another example is this well-known Fibonacci sequence, which is like we given the first two number 1, and the first two number is 1, 1, and then the next number will be the sum of the previous two number. 1 plus 1 you get 2, then 1 plus 3 you get 1 plus 2 you get 3, then 2 plus 3 you get 5, 3 plus 5 you get 8. So again, this one there are a lot of ways to realize. The most well-known way is this recursive function, recursively call the same function. Yeah, I think this is a better example to explain why I said the recursive function may not give you the good computational times. This one, another way is using the iterative way. I start from 3 onward, you count to n, and then every iteration I update the n minus 1 term and n minus 2 term. Then I will get the next value every iteration. And this one, if you look at this one, you will find that actually this one, the computation times is very expensive. Why? You can see, let's say my n is this one, n equal to 5. Okay. This recursive function, when n equal to 5, you need to recursive call this function 2 times by passing n equal to 4. Another one is minus 2, which is n equal to 3. Then when n equal to 4, you need to call the same function recursively 2 times by passing n equal to 3 and n equal to 2. This one, you need to pass the same function n equal to 2 and n equal to 1. Okay, this one no problem, you already stopped. Then n equal to 3, you need to do another 2 times. N equal to 2 and n equal to 1. So this one, when n equal to 5, you need to recursive 1, 2, 3, 4, 5, 6, 7, 8, 9. You need to call this function 9 times to find n equal to 5. Yeah, if you do some analysis, you will find that this one, the computational times is the function of 1 plus square root 5 over 2 power to n. And this module, we will not cover this, but just let you know. You will learn this, I think, in discrete mathematics. Yeah, but the computational time is exponential. Not surprising, you can see that this one, n equal to 3. Here, you repeatedly n equal to 3. When you have largest number, you expect that, yeah, you are repeatedly recalculate, yeah, n equal to 3 many times. And that end up that your computation times of this algorithm 4 is in exponential function. And this one, the computational times, yeah, not surprised, it's just a for loop. So it's linear. Yeah, all this we will cover in analysis of algorithm. And where did you get this number, the number from? This one, I think, yeah, I would say is beyond the scope of this module. I just let you know. Yeah, sometimes we can simplify it to saying that this thing is in 2 power to n. Yeah. This one, you will learn it in the discrete mathematics. I just let you know the computational times is in 1 plus square root 5 over 2 power to n. Yeah, you don't need to know how to derive it in this module. Yeah. And yeah, we will cover this big O notation, big theta in the week 3. Okay, when we cover the time complexity and how to represent the computational times, we'll cover in week 3. Yeah, here I just show you that when we decide, we should not rush to implement the program. A lot of time when we have one problem, we want to implement, we want to solve this problem, we want to calculate this Fibonacci sequence. There are a lot of solutions, there are a lot of algorithms can let us achieve to find out the solution, to find out the answer. But we need to analyze which algorithm is the best algorithm before we implement it. And you will find that, yeah, when you analyze the algorithm, you need to have some mathematics knowledge to do this calculation. Especially series, because you will find that in a lot of program, yeah, you need to run some for loop or recursive function. Yeah, a lot of time this involve the series. Yeah, maybe first iteration you do 1 calculation, second iteration you do 2 calculation, then you need to know, sometimes the third iteration you become 1, 2, maybe 4 iteration. Yeah, you do 4 computation. In the 4th iteration you do 8. Yeah, then what is the sum of 1 plus 2 plus 4 plus 8? That is a geometric series. Sometimes maybe your algorithm, you do the computation is 1 plus 2 plus 3. Then this arithmetic series. Yeah, so you expect that a lot of time when you analyze of algorithm, it involves some series. And another concept actually is in the mathematics revision I give you. Another concept, you may use a little bit probability because there's some if-else statement. So sometimes you may have this scenario, sometimes you may have another scenario. So that involves some probability. Yeah, but not a lot. I would say this module not a lot. You just need to know that, yeah, your program may not always run in that manner. Yeah, it can have a few scenarios, because if you have this scenario, this is the complexity. When you have another scenario, that is another complexity. What is the overall, the time complexity of this algorithm? you need to consider all the possible case before you can make the decision. So here you can see these two. Actually, there are another one. If this one is the exponential, this computation is in linear. Yeah, in fact, the best of this Fibonacci sequence it can achieve is in log n. Yeah, there's another algorithm because actually here if you take notes, you also repeatedly compute. You just your objective is find the n term. You don't need to count run a for loop to count every term. You can skip it. So that is So that is this Fibonacci sequence. There are a lot of ways to solve the same problem. But which one is the best one? Yeah, you will learn a bit in this module. And in 2101, you will learn more. So here, this one will be better than, this one will be better. If I compare the algorithm 4 and algorithm 5. And the problem type we will cover in this module, searching is one. Another one we will focus in the second half is a few graph problem. Yeah, graph problem is a big topic, but we only introduce the graph representation, breadth search, depth search, and some classical graph problem like backtracking technique, and also we will introduce another matching problem. And so that also involve the combinatorial problem. Then in 2101, next level, we will cover the sorting, the string processing. And there are other like geometric problem, numerical problem. Yeah, a lot of actually they are quite these few are very typical problem in computer science. Like what is searching is very classic, especially when you study the database. That one of the typical problem, you need to search certain key in the database. There are a lot of ways to search it. If your data is not sorted, it's unsorted data, then you want to search the key like 20 in this array. Probably you don't have other choice. So you have to do the linear search. That is kind of a searching. But if you in this module we will cover later in the second half. Of course, if you sort the data, then you can use the binary search, which we'll cover later. Then ultimately you will find that if you make a table, the hash table, you almost can instantly find out the key by using this kind of like a lookup table. Then application wise, like for example, if I want to solve the Sudoku, actually it's a kind of a searching. You're always trying to search along this column, along in this 3x3 queue, and from here to here, horizontally and vertically, which the number is not in use. One, maybe I can choose one, maybe I can choose two. That involves searching before you make a decision. So that is the application, one of the application. In our daily life, I would say a lot of real world problem, searching is part of the sub problem you need to resolve. A lot of time you're trying to search the answer. You're trying to search whether the key, the item, the particular things in the list or not. So searching is one important problem we will discuss in this time. I trying to cover this in different section together with the data structure. So when we cover the linked list, we will talk about this linear search together. And when we cover about the tree structure, then we will talk about binary search. When we talk about the table, we will talk about the hash table in the second half. Yeah. So another topic we will discuss in this module is the graph problem. Graph is another important problem, important tool for you to solve a lot of real-world problem. And yeah, it's a mathematical structure, consists of a collection of a vertex and edge. And the vertex and edge can be represent a lot of things, depend on the problem. So typical problem is the path searching. Yeah, you want to search from the source to the goal to find the shorter path. Yeah, this is a very typical graph problem. Yeah, there are a lot of solutions, and which one give you the best answer, best solution? Like just like you use the Google Map, and how the Google Map can give you the shorter path. Yeah, at the back end, they definitely use the there's some the topic we'll cover definitely implement in the Google Map. Yeah, when you provide two location, Google Map will trying to find the shorter path for you. How you can find the shorter path? Yeah, that in using the algorithm we'll cover in this module, and also in the 2101 will cover another one. Yeah, which can give you the shorter path. Of course, Google Map they considered more because they also considered the traffic condition, the junction, and so on and so forth. So all these additional constraints will make the path searching become harder. But in this module, we only cover the basic one. Yeah, but adding a few more constraints, yeah, you just need to modify the existing algorithm a little bit. So that is another one you will cover in this module. Another one interesting one is this combinatorial problem, which is very common in our daily life. A lot of time we want to solve certain problem, we need to consider all the possible case, all the possible combination, all the possible permutation, and before we can make the decision. And that sort of a problem, yeah, it's a combinatorial problem. We will cover a little bit in the last 2 weeks in the end of this module. Yeah, it can be applied in the cryptography. Yeah, when you want to send some message, you want to encrypt it, you want to encode it and decode it, and this encoder and decoder algorithm, yeah, involve the cryptography. Yeah, you need to make sure that you encode the message, in the other end decode it, you will get back the same message, and that involve that you need to consider all the permutation and combination of your message, and make sure your encoder always give you and decoder always give you the right result. So that is one typical combinatorial problem. Another one we will cover in this module is the matching problem. You have a few worker here, and you have different job. Different worker have different capability to do different job. And how do you assign the job to the worker? That is the very typical matching problem. Yeah. And then another one very typical is, yeah, we want to find a graph problem. Another graph problem is the cover problem. But yeah, covering problem. Covering problem means that you want to find the minimum number of vertex. The minimum number of vertex which those vertex are connected to the rest of the nodes, the vertex in the graph. in this example, yeah, these two, this one and this one, basically it connected to all the nodes in the graph. This is another kind of, yeah, but how do you find the minimum number of vertex cover the whole graph? That is another combinatorial problem. Yeah, there are so many combinations. And how do you know these two give you the minimum number of vertex cover the whole graph? Yeah, this is a typical combinatorial problem. And a lot more. Yeah, here I just show you a few examples. And I think in this module, we just cover this one. And cryptography, maybe in the 3000 or 4000 module, when they cover about those network security, they may cover a bit. Another typical problem you just now I've mentioned, like when you do the searching, you very soon you will realize that you need to sort your data. If you not sort your data, your searching will take long times will take longer times to find out the key. So sorting is another typical problem in computer science. We will discuss in 2101. Yeah. The application, for example, I want to find the top 5%. I want to find the median of the given data. Yeah. If you not sorted the data, like this example, you will find that you need to take some time to find out the median, right? Yeah, basically you find that first you need to sort the data first. I need to sort this thing to 1, 7, 15, 20, then 19, sorry, 19, 20, then 32, 53, and then 77. After you sort the data, the median you almost can instantly find out. But if you not sort the data, you will take a lot of time to find the median. So that will cover in the next level. Here, just let you know, sorting is another one. Yeah, and in the sorting, we also discuss about the stability. Stability is like when you have some data. Actually, when you need to sort multiple column. Yeah, like you want to sort the age of the student. You want to sort the age, maybe GPA. Yeah. So when you sort the age, then of course a lot of students have the same age. Then when you start sorting the GPA, you wish that you would miss out the age, the sequence of the age. So in that is the stability. Stability, that means you have a stable sorting algorithm. You will sort the repeated element in the same order that they appear in the input. Yeah. So this thing will be something we discuss when we talk about the sorting algorithm in 2101. So here I'm not going into too details about this. Another one we'll cover in the next level is the string processing. After you know how to do the searching, then we can, in the next level, we will talk about more sophisticated searching algorithm for searching a string in another string. Yeah, so-called string matching. Yeah, this one quite useful in our daily life. A lot of time you want to search certain text in the notes in the book. Yeah, that text matching is in use. Another example is, for example, now the COVID-19, every day there's an Omicron, there's a Delta, all this they have how do they know where there's a mutation in the sequence? Yeah, so that involve some string matching algorithm or string alignment algorithm. They need to align two DNA sequence from two different virus or whatever. Then yeah, they will find out that which portion there's a mutation. Yeah, that sort of things involve the algorithm. And you need a very efficient algorithm to do this, because this DNA sequence can be the sequence can be few megabyte data or few gigabyte data, and you have billion of this amino acids for you to check, to match. Yeah, the computation, if you have a good algorithm, can shorten your computational times. So this will be discussed in the next level. Other topic like computational geometry that maybe involve more mathematics, we will not discuss in this module and the next level. Yeah, if you're interested, you maybe can take like arithmetic geometry in the SPMS. Yeah. So that I'm not going to too details about this, but just let you know that is another topic. We also apply this thing in a lot of in computer graphic. In computer graphic, yeah, people will use this. Yeah, they involve a lot of this kind of computational geometric problem. So here, yeah, like for example, you want to find like the boundary of this viewpoint. Yeah, that is a convex hub problem. Given a set of points, you want to find the smallest convex polygon containing all the points. That is a computational geometric problem. One of the computational geometric problem. Another one, yeah, you give me a few points. Then I need to find to have to triangulate all these points, and such that there's no point in P is inside the circumcircle of any triangle. Yeah, that is the well-known Delaunay triangulation. Yeah, and that is involved a lot of, again, you'll find that in computer science actually involve a lot of problem, actually involve a lot in mathematics first before you can really implement the program. You want to solve, especially this one, you want to solve this problem, yeah, your maths must be good, especially in geometry, before you can implement it. Yeah, this we will not cover in this module, just let you know, just for your information. Another one is a very typical problem in engineering. Yeah, that is the numerical problem and the optimization problem. Because in engineering, a lot of time we will not be able to get the best answer. We only be able to get the optimum answer in engineering. And that is is another series of the computing problem. Yeah. Then you use the numerical approximation. One is like linear programming, is one of them. Yeah, which is trying to find the optimum. Is one of the optimization technique. Like I want to find the minimum of 3x plus 5y. I have some constraint, and 5x plus 3y must be greater than 29, and that is, if you convert it to the daily life problem, is like in economy, in engineering, a lot of time we want to make a decision. We have a few factors. Maybe for example in economy, we have the worker. X can be my staff salary, and then Y can be my resource, the cost of all the resource. Then of course I have some constraint. Yeah, I cannot hire too many people. I cannot have too unlimited resource. So all these constraint, given all these constraint, what is the optimum revenue I can have? Yeah, so that is a typical optimization problem we have in our daily life. And then, yeah, it can be solved by linear programming. Yeah, that is the optimization problem. That involves a lot of mathematics, and before you can realize it in a program. So this thing, again, we not cover in this module. I just trying to let you know these are all the possible programming problem. So all this problem, yeah, how do we solve this problem? Of course, you involve a lot of data, then you need to be able to well represent the data in the appropriate data structure. Then that can help you to solve the problem. That's why we cover in this module, we will introduce you the linked list. Array, you have learned it in the 1003. Then in this module, we will cover the linked list. Once you know the linked list, singly linked list, doubly linked list, circular linked list, and so on and so forth. Yeah, and we will cover the stack and queue. That's another kind of a special linked list. And also the nonlinear structure. You should be able to well represent your data. Once you be able to well represent your data, you can have a better algorithm to solve the problem. So, and recursive and non-recursive concept is involved in the implementation. Some, like especially the tree and some linked list and queue structure, you may need to use the recursive, the graph traversal, the tree traversal. All this you need to involve some recursive function when you implement them. Yeah. So this thing, once you know implement the data, able to select the appropriate data structure, then you will use the different strategy to solve the problem. Yeah, there are a lot of algorithm design strategy like brute force search, brute force exclusive search. Yeah, and we will cover. Then binary search is using the divide and conquer, or decrease or conquer. And then we also have some arithmetic expression conversion, or AVL tree, when we cover the tree structure. That is trying to, when you have a very when your data structure is very complicated, sometimes we will transform in another form first before we can solve it. Yeah, so transform and conquer is another strategy we will cover in this module. When we cover the matching problem, we will use this iterative improvement. That's why every iteration, you will get better and better result. And sometimes we will use the technique using the greedy strategy. Always search the best possible answer at the given information. Yeah. And then, yeah, that's a greedy strategy. So these few techniques, of course, there are a lot more design strategy, but in this module, we will cover these few. So yeah, that is what we will cover in this module. And yeah, just also let you know what you will learn in the future in the 2000 and 3000 module after this, and why you need to take this module. Yeah. So in this lecture, so I need to highlight is like algorithm is not just simply a computer program implementation. It involves the algorithm analysis, and also not only the implementation but also the analysis of algorithm. And then in this module, you will learn mainly the searching and the graph problem, and sorting and string matching, and other geometric problem, and the optimization problem will cover in the future in the higher level. This module will focus on searching and graph problem and graph traversal problem. And then lecture, we will just cover. I try not to cover too much about the implementation. Implementation will let you practice in the lab. So although the lab is not graded, but I strongly encourage you to attend all the lab section. Yeah, it's quite important. You don't expect you can practice all this coding overnight before the test. You have to, every week you have to go to the lab and practice your coding and do the assignment before. Yeah, it's not possible learn all these things in the last minute. Okay, tutorial wise will be, yeah, focus on the concept understanding and discussion and give you have a chance to clarify your doubt. Yeah, and then lab section is mainly focused on practice. And yeah, and also the assignment. Okay, so on, I think Friday I will cover the linked list and the pointer and all the dynamic. I think first I will cover the pointer and then the dynamic data structure, and if time allow I will cover a bit linked list on Friday lecture. Yeah, should be Friday. Yeah, Friday 10:30 to 11:30. Okay, that is today lecture. Any question? So practice only can be done in the lab. And also, I strongly encourage you to install the code block first. Yeah, in week 1. And yeah, you can practice at home. The lab is not compulsory because it's not graded, but you are strongly encouraged to attend the lab section because that is the only chance you can practice, and there are some teaching assistant there to help you. Okay, any question? If you have any question, you can drop the email to me. Yeah, this is my email address. Do you have any recommendation book? Hey, I think it is in the notes. I have the, yeah, I for algorithm wise, I think this is the common one is one. Yeah, but this one can be used not only in this level, also the 2101. Other ones, there's a design. Yeah, what is the, yeah, another book. What is the name? Yeah, Introduction to the Design and Analysis of Algorithm. Yeah, this is another one. I think it's not bad. But all this book, you will find that they are not teaching you how to implement the algorithm. They're more focused on the pseudocode and analysis of algorithm. Tutorial is, I don't know why the school arranged all the tutorial section and as online. I think mainly online. Probably due to the class size, yeah, they won't be able to find appropriate place for the tutorial section. So the tutorial class will be online. But this module, have to take notes. This module we only have 6 tutorial. It's not every week. Is, yeah. So just take notes the schedule. Lab is almost every week, but tutorial is not. I put in this order so that if you have any problem after the lab, you still have a tutor there, you can clarify your doubt. But if still not enough, then you probably have to, you can drop me an email or arrange some consultation. Yeah, to clarify your doubt. I suggest is like whenever you have any doubt in after the lab section or tutorial, you should clarify as soon as possible. Don't wait until last minute. So because this module, yeah, if it's not something you can learn in the last minute, especially the programming, the coding, it will take a lot of time to practice. And the lab test is not something you expect that the lab test, the question is not something from the lab or assignment. So this module is not ask you to memorize the code for the test. Yeah, you need to be able to solve the real world problem. I mean, we expect is that you're able to, we give you a problem, you need to analyze the problem and understand the problem, and then you come out your own algorithm, select appropriate data structure, and then you implement them. Other than ask you to go and we will not let, we try not to let you go and memorize certain things and then to implement, recall, to memorize, and then reproduce the same code during the test. That is not what we want to do in the test. Okay, I think everyone left. Okay, if you have, if there's no problem, that is today's lecture. Okay, see you on Friday. Bye.